I will try to make a short presentation. I mean, we know each other. We met the previous 2 days. But in this session, I would like to present to you the research that we are doing with Stereos in the lab. Also in line with what we will start here in Greece with Archimedes. So yes, I will try to give an overview of actually the main motivation on the topic that we are working on, and some more technical or more engineering-based advances that we have currently. And at the end, I will just present and discuss with you our ideas about Archimedes. So I guess more or less this is something that we are discussing through the entire summer school. Everybody is discussing about AI and how this can affect precision medicine. But actually, if we want to do a kind of to have a kind of definition about what precision medicine is, we can say that it is actually the methods or the domain that tries to identify phenotypes of the different kinds of patients and find out how well treatment will respond to with respect to the particular phenotype. And indeed, the last, let's say, 5-6 years, there is a lot of attention on how we can use AI to do this kind of stratification, to identify these phenotypes, which on one hand they can be actually they can be guided of things that we do currently in the medical and the clinical practice, or they can be actually something new or some kind of new biomarkers that we can identify through by just using a lot of data and a lot of kind of different kind of information. And indeed, this kind of research and studies that shows that AI can actually have an impact on precision medicine, they are actually summarized on very high impact journals, like for example Nature, Science, and so on. And we can see more and more these kind of tools that they are integrated on really medical and clinical problems. And actually in our lab, what we are focusing on how it gets a lot of attention. So once more, I would say that the engineers, they were a little bit faster than the lawyers, because again we have the algorithms, but we don't have the way or the frame to use them properly and to adapt them in a safe way into our everyday life. And okay, this is one more actually algorithm that it has been actually published 1.5 months ago, and it has been published from Meta and Facebook, and indeed it is a huge model that has been trained again on a huge amount of data, and it can give us annotations and segmentations of objects in a very, very accurate way. So again, there is a lot of attention on how we can use this algorithm and adapt it, and there are already papers. Even, again, this paper is on arXiv, it's not even peer-reviewed, and there are already papers that they are trying to adapt it into the medical domain, and they can actually indicate that we can actually use this kind of method and we can perform very well with respect to the current state of the art. So overall, I wanted to discuss some kind of new kind of learning that we can use, but I think I don't have the time to go into details for this. What I would like to say, closing this very short presentation, and you can ask me more if you want to, is that actually deep learning in general, it will really affect precision medicine. I am really convinced about that. Currently, the algorithms, they are not as well adapted into the clinical practice as we would like to. They are more in the research phase, even today. So actually, we need, again, to understand why this is happening and how we can facilitate this process. These kind of new models, that they are these large models, I think, in my personal opinion, is that they are very powerful and they can really adapt and give insights on the medical domain. So there is a lot of kind of research directions how we can adapt them and how we can use them on different tasks. And of course, I saw this kind of cell cover about cancer that indicates that all this kind of thing that we do, it's really difficult, and we need a lot of interdisciplinarity. We need engineers, we need doctors, we need to work all together in order to untackle not only the algorithmic, but also the medical problems that we have. So that's all from my side. Thank you very much.